Omber is a new vector drawing tool that I've made. What makes it different from other tools is that it is built on a new type of shading engine that supports new ways of making gradients. That means you can make drawings with smooth shading and subtle color blending. During this presentation, I'll give an overview of existing gradients technology, describe how gradients work in Omber, and give a demo of Omber's gradients in action. Omber is a vector drawing program like Illustrator, SVG, and Flash. As a vector drawing program, Omber lets you make art by describing the shapes that make up a drawing. This is different from programs like Photoshop, where you make art by painting pixels with a brush. Photoshop and other photo editing programs are raster graphics tools, and a lot of people find them to be more intuitive to use than vector graphics tools. And this sort of makes sense, because raster graphics programs are designed to imitate the feel of painting with a real paintbrush. But if raster paint programs are more intuitive than vector drawing programs, why do people still use vector graphics? Traditionally, people have said that infinite scalability is the main reason for using vector graphics. This means that you can take a drawing and scale it to any size without any loss of detail. If you draw a small icon in a raster paint program and then scale it up, you get a bunch of blocky pixels. If you draw the same icon with a vector drawing tool and scale it up, you get a nice, crisp image. A vector drawing tool is able to do this because you have to specify the shapes that make up your drawing. A computer knows that the icon is a circle with an eye inside of it. When you scale the drawing up, the vector drawing tool can draw a larger eye and a larger circle at the resolution you need. And this sort of infinite scalability is useful for making really large posters because you can work at very high resolutions with no loss of detail. It's also useful when you have to make a lot of icons at lots of different sizes. For example, cell phone screens come in lots of different resolutions. So to make an Android cell phone icon for an app, you have to supply icons at 7 different sizes. Instead of having to draw 7 different icons, you can just have one vector version and then create different sizes from that vector drawing. Although this infinite scalability stuff is true, it's actually not that important anymore. Computers nowadays are fast enough and have so much memory that many designers just make giant images with much more detail than necessary, and then scale the images down to whatever sizes they need. I think the most useful feature of vector graphics is that the art is much easier to manipulate and change. You make a vector drawing by specifying shapes to the computer. Shapes are a much higher level representation of a drawing than just a bunch of pixels. Because of that, the computer actually understands what's in your drawing. As a result, you can take those shapes and tweak them, resize them, or recolor them. For example, suppose you draw an OK button. If the computer knows about the text on the button, then you can easily change the text to something else and make a cancel button, for example. If the button were just pixels, you couldn't do that. Since I'm not an artist, this higher level representation stuff is actually really important to me. I can never draw things right the first time. I don't have enough experience as an artist to know how things should look before I draw them. So I always draw things the wrong size or parts that are in the wrong place, and I need to constantly tweak things before it looks reasonable. If I were to draw a stick figure in a paint program, and then discover that the head is too small or the arm is crooked, I would need to erase those things and start again. But a vector drawing program knows about circles and lines, so I can just go in afterwards and move the line or make the head bigger without needing to start over. This ability to adjust and tweak things is also useful in animation. If a computer knows what shapes are in your drawing, you can just say how you want those shapes to move over time, instead of having to draw a separate drawing for each frame of animation. Since one of the most important aspects of vector design programs is the ability to tweak and alter your drawings, it's important for those programs to have good tools for specifying and altering shapes. And that's what I've been trying to do with Omber. Omber is a new vector drawing program that I've made, and it's basically my dream vector design tool. For years, I've been frustrated with how other vector programs worked, and I've always wondered why they couldn't have richer tooling or more flexibility. And eventually, I just got so annoyed that I decided, hey, I'm a programmer. I'll just make my own program with the features that I want. I've written the program from scratch, and along the way I've tried to rethink how vector tools should work. Most vector drawing tools use the same underlying model for vector graphics, so they all end up with the same limitations. Instead, as I've built my tool, I've kept asking the question, what happens if I were to relax these restrictions to give designers more flexibility and more freedom in how they specify their shapes? Can you do something really cool with that? And it turns out you can. The main advance in Omber, though, is a custom rendering engine that specializes in advanced gradients. In Omber, everything is a gradient. Gradients are the fundamental drawing primitive in Omber. And this design gives you the power to make art with complex shading and subtle blendings of colors. To understand the power behind Omber's gradients, though, it's helpful to know how gradients have traditionally worked in other vector drawing tools. Normally, when we think of vector art, we think of shapes filled with solid colors. That's because in vector graphics tools, it's easiest to specify shapes with flat colors. You get a clean, flat look. I like to call it MS clip art style. Although it's limiting to only use solid colors in a piece of artwork, you can still do some really great art with it though. Most drawing tools support simple procedural gradients. With these gradients, you are basically describing some simple math for how to fill colors across a surface. The most common of these sorts of gradients is the linear gradient, where you tell the computer that you want one color on one side of a shape and a different color on the other side of the shape. Procedural gradients are commonly used to make a piece of vector art pop a little bit. If you take a piece of vector art with solid colors and replace some of those solid colors with simple gradients, it adds a little bit of sizzle. It just feels a little bit more alive. It's possible to use these gradients to make more complex shading, but it's really hard and requires lots of skill. The problem with these types of gradients is that it's hard to specify complex gradients that fill odd shapes or that span multiple shapes. The gradients are too simple and too limited, so it's hard to get the colors between shapes to line up. So you get these visible seams everywhere. A skilled artist can still use these simple procedural gradients to make some very realistic drawings. They can make use of blur filters to blur the colors along seams so that you can't see the seams anymore and everything looks smooth. The problem is that not every tool supports these sorts of blur filters, and you have to be a very skilled artist to know how to apply them to get the effect you want. And afterwards, you end up with such a complicated mix of shapes, gradients, and blur filters that it's hard to manipulate the drawing later. You end up losing one of the benefits of vector drawing tools, which is the ability to easily tweak and change your drawing. Some of the more advanced professional vector graphics tools have support for something called a gradient mesh. These are really nice, but they also have some heavy limitations. Mathematically, a gradient meshes are extensions of Bezier curves. You take Bezier curves and extend them to 3 dimensions so that you have a Bezier patch where you can control the height and shape of the patch using different handles. The higher that a point on the patch is, the lighter the color is there, so it ends up being more white. The lower that a point on the patch is, the darker it is, so it ends up being more black. The way these patches actually work in drawing tools is that you end up with a grid. So this is the same 3D patch we saw before, but just viewed from above. You can assign different colors to different points on the grid, and the colors will be smoothly blended across the grid surface. Unfortunately, not everything is shaped like a grid. To make something like a ball, you have to squish in all the corners and move all the points around until you get something that looks ball-like. But you can't do those sorts of distortions with every shape. Some shapes have holes in them, or if you're drawing a person, it's hard to distort a grid into a human shape because people have all sorts of appendages and other things sticking out, and a grid doesn't really fit those sorts of shapes. Another issue with gradient meshes is that you have to assign colors to all the points on the grid. But because it's a grid, you sometimes have points in places that aren't interesting. You have the wrong level of detail in the wrong spots. For example, on the border of the ball, I want it to be red on the bottom and orange on top. But there are 12 points around the outside of the ball where have to assign colors. It's just a lot of extra work for me because I don't really care what the exact color is for a lot of these points. I just want the computer to figure it out, but I still have to assign all of these colors. In research labs, they have more exotic gradients in the works. Right now, one of the most promising ones is called a diffusion curve. Basically, you draw a bunch of lines, and you assign different colors to different points on the line. Then, the computer will diffuse those colors outwards across the canvas, so the colors will spread out and blend together until you get a very smooth mix of colors. It's sort of hard to make a practical drawing tool from this technology, though, so it's mostly in the lab still. Omber draws inspiration from some of these techniques, though, to give you a new type of gradient with similar power. So, advanced gradients are at the heart of Omber. In fact, everything in Omber is a gradient. I think artists should be able to make use of subtle shading and color blends anywhere in their art. So the fundamental drawing primitive that you use to make everything in Omber is the gradient. The way that gradients work in Omber is that whenever you draw a shape, you can assign different colors to any of the points along the edges of that shape. And Omber will automatically blend those colors across the shape, giving you a gradient. You can do this on any shape. It can be concave, or have curves, or whatever. Omber will figure out how to smoothly blend the colors across the surface of the shape. Although creating gradients in Omber is easy for the artist, the actual math behind drawing them is pretty complex, actually. That's why these sorts of gradients haven't been done before. You might think, oh, I've seen some 3D models with some smooth shading across them, so it can't be too hard. It turns out that all those 3D models are made up of lots of triangles, and making gradients over triangles is actually easy. If you assign 3 different colors to the different points of a triangle, you can then just linearly interpolate the colors along the edges to get colors along the edges. Then, you can interpolate the colors between edges to get colors in the middle. And no matter how you do this, you get some nice, consistent coloring. But once you go to shapes with more than 3 sides, everything falls apart right away. There's no easy, consistent way to calculate the colors in the middle of those shapes. Intuitively, you might think, oh, we know how to do gradients on triangles, why don't we just break up more complex shapes into triangles and do gradients on those triangles? But that doesn't work. Consider just a square with different colors on the corners. If you divide up the square into triangles like this, then you have gray colors on either side of the triangles, so you end up with gray in the middle of the square. But if you divide up the square into triangles the other way, like this, then these triangles have blue and red on either side, so it should be purple in the middle. So even with this simplest shape, you end up with different colors in the middle, depending on how you divided it up into triangles. And things just get even worse as you get to more and more complex shapes. Omber then goes a step further. Although Omber's gradients are powerful, sometimes even that's not enough. Sometimes you draw a shape where you want certain colors on the inside of the shape. So with this ball, we want it to be gray around the outside, but white in the middle. If you make a circle in Omber, Omber only lets you assign colors to the outside of the circle, so it's not possible to put a white color in the middle. To let you make these sorts of gradients, Omber lets you combine shapes together into an arbitrary mesh. So we can split the circle into a mesh of 2 shapes. Then we can put a white color along the boundary of the 2 shapes, and we can get the gradient we want. This is different from the gradient meshes that I showed before, because the mesh isn't restricted to a grid. You can combine any type of shape together in any way you want, so it's a lot more flexible. This way of modeling things using meshes actually feels a lot like 3D polygon modeling tools. And Omber borrows some ideas from there about how the workflow should work. Now it turns out that calculating gradients over meshes makes things even more complicated. So let's say you have a mesh of 3 shapes, where it's black on the left, then yellow and blue in the middle, and then green on the right. If you just naively calculate the gradient for each shape separately, then you end up with some visible seams where the different shapes join together. If you look at a graph of the colors from left to right, you can see why this happens. Even though the colors of the different shapes line up properly at the edges, the transition isn't smooth. There's an abrupt change at the seam, and you can see that as a visual artifact. So to properly color a mesh of shapes, Omber needs to look at all the colors throughout the mesh to find a gradient that smoothly transitions between all the shapes. I had to write a special rendering engine called the wrinkle-free gradient engine, specifically for doing gradients in meshes. And you can see that the result is much smoother and with fewer visual artifacts than just a naive approach. Here's a diagram of the different stages of Omber's rendering pipeline for calculating gradients over shapes. There are two takeaways here. The first is that Omber is built on a modern architecture that renders everything to WebGL at the end. The Omber pipeline outputs 3D triangles that can be displayed really quickly on the screen using 3D graphics hardware. The second takeaway is that calculating a high-quality gradient is actually a little bit slow, but we still want the program to be quick and responsive. So what Omber does is that it has one quick path on the left in the diagram where it calculates a rough gradient as quickly as possible and displays it to the screen right away so that you can quickly see the effect of your changes. But Omber also has a second thread that calculates high-quality gradients for shapes in the background, and it will update the screen with the higher quality versions as they are calculated. So right now, I'm the only developer on Omber, and I wanted to make it available on as many different platforms as possible. So I've come up with this sort of mess of an architecture where I take Java code, compile it down to JavaScript, and then I'm able to get that JavaScript to run on many different platforms. You can run it on PC, Mac, and Android. You can even run it in your web browser. There's no iPad version yet, but I already have a Mac version, so it should be pretty easy to port once I get around to it. So here's some sample art of things made in Omber by me and some other people. Keep in mind that I'm not really an artist, so you could probably do better. But yeah, let me show you with the demo of how Omber works. So this is Omber. In Omber, the main toolbar of tools is on the left here. And then there's also a toolbar on top with additional commands depending on which tool you're using. On the right, there's your most commonly used colors, plus something for changing the width. So Omber, like traditional vector drawing tools, they support drawing different shapes. And you can draw lines. And you can take those shapes and move them around or resize them, or you can sort of reshape them, convert between curves and lines and things like that. So this is basically standard vector drawing stuff. But like I mentioned, the thing that makes Omber different is that everything is a gradient. So you can take any shape and you can take any of the nodes along the outside of the shape and assign different colors to them. And Omber will automatically take those colors and blend them across the surface of the shape until you get a smooth gradient across the shape. Another neat thing in Omber is I tried to relax sort of a lot of the traditional constraints in vector drawing programs. So this gives you a lot more power to draw things the way you want. So if you take a line, in most vector drawing programs, lines have a width and a color. But in Omber, you can take any point along the line and have different widths and different colors. And this just gives you a lot more flexibility in what you can draw by relaxing those constraints. So another way this philosophy shows up in Omber is in strokes and fills. So in traditional vector drawing tools, whenever you draw a shape, the shape can have a stroke or a fill. So in this case, I've drawn a simple square, and it can be filled with, say, a green color. Or you can have a stroke, and a stroke is basically a line that goes all the way around the shape, giving you an outline. Now, Omber tries to rethink this, and it goes, why can a line only go entirely around a shape? Why can't you have a line that only goes over part of a shape? Or why can't you have a line going around more than one shape? Isn't that sort of more flexible? Doesn't that give you more power? So what Omber does is, instead of strokes and fills, it has this idea that you can draw lines and you can weld lines to shapes. And with that, you can get the same power as strokes and fills, but lets you do other things as well. So here, there's a drawing of a hat. So we have the crown on top and sort of this brim on the bottom. And the problem with this drawing is at the boundary of the hat, everything sort of blurs together. So it's hard to see the two parts of the hat. So it'd be nice to have a line between the two parts so we can see the difference between the crown and the brim. So if I wanted to do that, I can just switch to the line tool and choose a color. And I'll use this follow segments mode, which automatically welds a line to a shape. And what I'll do is I can draw a line here that only goes around part of a shape. So now we have this nice little line that shows the separation between the two parts of the hat. Another thing we can do is maybe we want to have an outline going around the hat. Now the problem here is the hat is made up of two different shapes. And in a traditional vector drawing tool, you can't have an outline going around two shapes. But in Omber you can. So here I'll use the line tool again, have a different color, and I'll just draw an outline that is welded to the two shapes. And it's as simple as that. I now have one outline here that only goes around part of one shape to show the separation between the hat and the brim. And I have this other line here that goes around two shapes, showing an outline of the hat in total. And the thing is, these lines are welded to the shapes underneath. So when I modify the shape, it also moves the line. So I can make the hat taller, or I can sort of maybe bring it down and create a little fedora look. But the lines are welded to the shapes, so they move together just like strokes and fills, but it's more flexible than a stroke or a fill. So to draw very complex gradients in Omber, you have to make use of meshes. And making meshes is pretty easy. So let's say I wanted to make a ball that has some shading. I'll just create the ball first. Here we have a blue ball, and let's say I wanted to have a white highlight here and have it be darker on the bottom. So to get a white highlight in the middle, I'd have to split the shape into two. So now this shape has been split, the ball has been split into the shape on the bottom that's welded to the shape on the top, creating a mesh. And I can add a point in the middle and so move it down. And I can assign it a lighter color. And I want that color on both sides to create sort of this white highlight in the middle of the ball. But you'll see that there's a bit of an artifact here in that you can sort of see the seams. But if I turn on the wrinkle-free engine, it sort of smooths that out. So you get this nice smooth transition where you don't see the two different shapes anymore. There's a lot of sort of white on the bottom, and I want it to be darker underneath. So what I'll do is I'll first darken these two nodes. And I want sort of more blue in the middle. So what I'll do is I'll add 2 points here. I'll make those 2 points be normal blue, and then I'll split them. So now we have this shape here, which is dark blue on the bottom, but normal blue on top. And then I have this other shape here, which is blue on the bottom, but has a white there. And I want to push this blue further down to make the shape more round. And here's the final shape. So even though it's a mesh of 3 different shapes, Omber smoothly blends everything together. So it looks like just a single ball. And you'll notice the workflow, while building this ball, it feels a lot like a 3D modeling program where you're working with the mesh and adjusting the mesh and adding points and things like that. And that's intentional. I borrowed a lot of the workflow from 3D modeling tools because people already use them for working with meshes. So now I want to show you how to make a more interesting shape in Omber. So here I have a photograph of an apple, and I want to use Omber to make a vector version of this apple. Now, the first thing you need to do is you have to figure out the colors that are inside this apple. And it's actually hard to figure out the colors of an object from a photograph because all the colors sort of blend together. And it's hard to know, like, is this red actually different from this red down here? Or are they the same red? It's hard to know. So what I usually do is I create a version of the photograph where I reduce the palette, so I reduce the number of colors in the photograph, and this makes the main color regions really come out. So we can see that there's this darker red here and on the bottom, and there's this main red in the middle, but there's a lighter section on the side and on the top here. So once you have this reduced color version of the image, you can then figure out what shapes you want to draw. And the tendency is to want to draw shapes that follow the regions of colors. So here we have this dark red region. So the tendency is to want to draw a shape that follows this dark region. But in fact, here I've sort of drawn out the shapes that we want in advance. What you actually want is you want shapes that go between regions. So here I have a shape, and the shape starts in the middle of the dark region, and it goes to sort of this middle of this regular red region. That way, this shape, it will have a gradient that goes from the dark red to the middle red smoothly. So once I figure out what the shapes I want are, I can then sort of draw the shapes. So I'll do that now. So here, let's start here by drawing this red shape here. Okay. And then here, I want a shape that's red on the bottom, but dark red on top. So I want these 2 points to be this darker red. And then I want another shape here, which is dark red on the bottom, but regular red on top. So I'll fill in these shapes. But I want it to be a normal red here. This shape here is a little bit complicated because it's dark here, red elsewhere, but then a lighter red up here. But let me draw it and see what happens. So in this case, I want the dark red here to match the red up here. So I'll take this point and I'll copy the color over to the other shape. And then I want a lighter red for these points there. And I also want this color here to match over here. Good. And then I want this final shape here. Okay, so I want this red from this shape to match the red over here. So I'll just copy it over. And I think I want this dark red of these two shapes to also be on the bottom. So there we go. So here we have sort of all the smooth colors of the apple. And to top it off, I sort of want this stem on top. All right, so I'll move it to the front. And I'll position it on top. There we go. So now this is looking very much like an apple. To really make it pop, what we want though is we would want this little white highlight here. So what I've done is I've sort of drawn the highlight in advance. What the highlight is it's actually two circles. So we have this one circle that's white in the middle, but it sort of fades out on the side here. And then we have this other circle here that fades out even more. So what I'm going to do is I'm going to take this sort of outer rim of the circle, and I'm going to just reduce the transparency to nothing so that it sort of totally disappears. And then this highlight's a little bit strong, so I probably want to increase the transparency there as well so that the highlight is not so strong. There we go. And now I'll take this highlight shape, bring it to the front, and I'll position it right about here. And there we go. It's a pretty nice apple, and it was able to be done pretty quickly in Omber, and it has the nice sort of dark shading here and a lighter shading up here and this strong highlight. One of the neat things is that once you have an advanced gradient engine like Omber does, you can start using it for things besides normal gradients. So here I have a photograph of an arm, and I sort of cut it up into this arm-like shape. And this photograph is actually still a gradient. So if you use sort of 3D graphics terms, this is basically a shape with a texture that is texture mapped onto the shape, and the UV coordinates form a gradient, and you can then control these UV coordinates through Omber. And basically what this means is that you can warp the image in Omber. So I can alter the image just like it's any other shape, and by doing so it will warp the image and do these neat image warping effects. So one thing I can do is I can take this arm here, I can convert it to a curve, and I can, move it up to give sort of some muscles here. Or I can do even crazier distortions. So I can actually move the whole arm down here, and I can reshape these pieces. So I can unbend the arm by changing the shape, and the shape will be distorted through the gradient to unbend the arm. So yeah, you can do all sorts of crazy things using gradients. It's not just colors. You can use gradients over textures, and you can get some really neat effects in Omber by using gradients in these ways. So as you saw during the demo, Omber works and is very usable. Right now, Omber works fine for small and medium-sized drawings, but if you make really intricate, complex drawings with lots of shapes, Omber starts to chug a little bit. So I eventually would need to go in and fix up some performance issues if you want to be able to use Omber for larger drawings. I've also been mainly focusing on getting Omber's gradients to be solid, so I haven't had time to implement some traditional features of vector drawing tools, but I'll hopefully get to them soon. Well, thanks for listening about Omber. It's really easy to give Omber a try. If you go to the Omber website, you can even run it right in your web browser, so please do try it out. And if there are any changes or features that you want, then just let me know and I'll gladly try to make the changes for you. Thanks again, and give Omber a try.